Good morning. Today we are going to discuss on the fundamentals of AC circuits. That is how an AC is generated, how an alternating current is generated, and what are the important terminologies used in this AC circuits. Good morning. Today we are going to deal with the fundamentals of AC circuit. What are the different terms used for AC circuits? So we are starting firstly with our basic terms. In the slide we can see an AC sinusoidal waveform I have given, and I have represented the main important terms. First one is the amplitude. Amplitude notates the maximum value attained by the quantity, that is, it is otherwise known as the peak value or maximum value, and is notated by capital letter V, small letter m for maximum. So Vm, or we can call it as Vmax for a voltage waveform. And the second one is the time period. Time period is denoted by capital T. That is, the time taken to complete one cycle is called the time period. So here the time, it is a time taken for the waveform to travel from 0 degree to 2 pi or 360 degree. That time is known as time period. And what is a cycle? It is a cycle is the consists of a positive and a negative part, and the complete one is, we call it as a cycle. So cycle repeats. Cycle is the non repeating part. It is a repeating section of a waveform. We can call it as a repeating section of a waveform. And these are the three main. One more is there, that is instantaneous value. That is, it is the value of the quantity at any instant. Here it is V, and the instantaneous value is usually notated by small letter. The next important term is the frequency. Frequency is how many cycles per second, that is number of cycles per second, is known as the frequency, and it is usually denoted in terms of hertz or cycles per second. So the frequency and time period are related. What is the time period? Time period is the time taken for a cycle, that we call it as a time period. And here a frequency is the number of cycles per second or in 1 second. So if the frequency is f for a second, then in 1 second how many cycles will be there? 1 by f cycles will be there. So we can say T is equal to 1 by f. That is, in our domestic system we say f is equal to 50 hertz. That is, in a second it has 50 cycles. That is 50 positive half cycles and 50 negative half cycles, or it crosses the zero real axis or the zeroth position 100 times. So from this we can calculate the time period. If frequency is 50 hertz, then time period for a cycle will be equal to 1 by 50, that may be 2 milliseconds. So the next important term is angular frequency, and it is the angular frequency. So it is the radians covered in 1 second, or it is angle covered in 1 second, or angle is measured in radians, so it is the radians per second. So unit of the angular frequency is radian per second, and it is denoted by usually omega. It is denoted by omega, and it is equal to 2 pi, that is total cycle per time. So one cycle it is T. So that is equal to 2 pi f. What is the relation between this frequency and speed? This is an important relation we need in our problems. So what is the relation between frequency and speed? I am considering a coil which is rotating at a speed of n rpm. Rpm is rotations per minute. So if we are doing our problems in SI units, that is, it has to be converted to rotations per second. Minute should be converted into second. So for 1 minute it is n rotations, then for 1 second it should be n divided by 60. So a coil is rotating at a speed of n divided by 60 rotations per second in the field consisting of p poles. So when a coil covers a north pole and a corresponding south pole, it travels 0 to 180 positive cycle for a north pole, and south pole it will come to 180 to 360. So it rotates 360 degree, that is one cycle will be completed when a coil passes through a north pole and a south pole. So in one revolutions it will be covering p by 2 cycles. So 4 poles are there, 2 poles it carry one cycle. So 4 poles it will carry 2 cycles, that is 4 poles 2 cycles, 4 by 2 p by 2 cycles are completed. So what is a frequency? Frequency is the number of cycles per second. So in one revolution p by 2 cycles are generated. So frequency is equal to number of cycles per revolution into number of revolutions per second. Number of cycles per revolution into number of revolutions per second is the number of cycles per second. So number of cycles per revolution is p by 2 and number of revolutions is n by 60 since it is converted to second. So we will get pn by 120. Usually we remember it with the equation what f is equal to npn by 120, or for an AC system which is running in synchronism. Synchronism means the frequency will be same everywhere. At that time we have to find out the speed. So n is equal to 120 f by p. That is the equation we usually uses. So this relation is very important as far as electrical is concerned. So these are some problems. You take your own time and do the problem. So I will check it after 10 minutes. Okay. So in the question it is given the maximum current in a sinusoidal AC circuit is 10 ampere. So I is equal to Im sin theta, that Im is equal to 10 ampere. What is the instantaneous value? That is, what is I when angle is 45 degrees? So I is equal to Im sin theta. So sin 45 we have to find out into maximum value 10 will give you the answer. See the waveform and do it. Next question is, write the mathematical expression for 50 Hz sinusoidal voltage with a peak value of 80 volts, that is Vm is equal to 80 volt. Then we have to draw the waveform. Okay, so we will find out how we can draw the waveform. That is, it is given frequency f is equal to 50 Hz. Then Vm is equal to given. So we can write from the general equation V is equal to Vm sin omega t, and omega is equal to 2 into pi into f. So that is 100 pi. 50 Hz, that is 100 pi, and pi is 3.14. So 100 pi is 314. So omega t is 314t, and V is equal to Vm sin omega t. So Vm is 80 sin 314t. That is the equation. Next, they are asked to sketch the waveform. So we have to find it out for different time period. So what will be the frequency? It is 50 Hz. So one cycle it will be 20 millisecond. So half cycle it will be on 10 millisecond, and 90 degree it will be on 5 millisecond. We can draw like this. Another question, this is a university question, it is very important. An alternating current is given by an equation. We have to find the maximum value. So Im sin omega t, that Im is 141.4. It is very easy. So the maximum value is 141.4. Then frequency, what is frequency? Frequency is 2 pi f or omega. Omega is equal to 314. So f is equal to 50 hertz. Then time period, what is the time period? That will be 20 millisecond. No, 50 hertz, 1 by 50, that is 20 millisecond. And what is the instantaneous value after t is equal to 3 milliseconds? So we can just simply substitute that t is equal to 3 into 10 raised to minus 3. We will get the answer. In this is an important question, university question. We have given the value equation for current I is equal to 10 sin 942 t, and we have to determine the time at which it reaches 6 ampere for the first time and the second time. For the waveform, you will get the idea, and for this we have to find out for one cycle what will be the current what will be the time period for one cycle. It will be omega is given as 942. So omega is 2 pi f is equal to 942, and f is equal to 942 divided by 2 pi, and what we will get, and that time period t is equal to inverse of it, that is 2 pi 942. 2 pi f is equal to 942. So f is equal to 942 by 2 pi. Then t is equal to 2 pi by 942. You will get the values of millisecond. Then that is one time period, uh, one time period, or time for one cycle. Next, what we are going to do is we have to find out the time to reach 6 ampere. So we will substitute the instantaneous value 6 ampere in 10 sin 942 t. So 6 is equal to 10 sin 942 t, or 0.6 is equal to sin 942 t, or we can say 942 t is equal to sin inverse 0.6. We will get some angle in radian. So that is t is equal to that angle in radian divided by 942. You will get some milliseconds, that is 0.68 millisecond. That is the first time period to reach 6 ampere. The second time period, what we have to do, one cycle that we already know, 2 pi by 942 plus this 0.68 millisecond will give the time to reach current for second.